Line segments, rays, and lines. Our number one lesson in Chapter 4, learning about the basic concepts of lines, line segments, and rays, and visualizing them in the real world. Yes, from this video, we are starting Unit 4 of our year's lessons, and it's going to be including lots of angles, geometry, shapes, stuff like that. So I hope you'll get excited. Okay, yes, this is our first lesson for Chapter 4, and this is actually a little build off of Chapter 1, some of the basic kind of 2D shapes we've learned about, or 3D, sorry, and learning goals. Understanding the relationships between lines, line segments, and rays, and knowing how and use different methods to represent lines, line segments, and rays, and understanding the meaning of 2 points form a line. That's something we will be learning in this lesson. So here's an introduction. This, of course, is a railroad. This highlighted red lines right here of the track, what do you think it's representing? What do you think it's representing? And then this flashlight. What do you think this is representing? Light beaming out of one point, which is the flashlight. It goes straight out like that. Think. The light emitted by the flashlight, the straight rails going on and on forever onto both sides. What simple 1D figures do they demonstrate? What 1D figures do they demonstrate? This flashlight, it starts at one point. It starts at one point, but it keeps going on in the other. What do we call this? A ray. And then, of course, there's going on and on forever onto both sides. What does that demonstrate? A line. A line goes on and on forever. So now we're going to start our class with that quick little warm-up. Lines, line segments, and rays. Think, how can you see the following figures as part of the real-life world? Line segment CB or BC, segment B, ray OB, line EF or FE. How can you describe these? How can you visualize them and put them in the real world? Oh, and sorry, of course, there's line A. So number one, it's referred to as line AB. I want you to see how they are marking these. There's a line, and then on the line, not at the ends, on the line are the uppercased letters A, point A, and B. Remember, when it's expressed this way, it has to have capitalized letters, and that will be referred to as line AB. Just so you know, if A was here and B was on the other end, this wouldn't be a line anymore, it will be a line segment. So to show that it keeps going on forever on both sides, we don't do it exactly at the end, the points. So that is referred to as line AB. Is that correct? Yes, that is. Second, it is referred to as ray PO. I want you to think about this. Incorrect or correct? If you said correct, you are incorrect. The answer is incorrect. Yes, so the answer is incorrect. Rays are the only, okay, so I'd better write it down. So rays are the only 1D figure, 1D figure that, so rays are the only 1D figure that needs to be marked. Okay, I'm not going to write this down. So there's two less space. But anyway, so rays are the only 1D figure that when you mark it, there is a order. There is an order. The reason this is incorrect is that the letters in ray PO, it's first a P, then a O. The first point we often think of as the starting point, the end point of that ray, or the starting point of that ray. So what ray PO would look like would be P and then O. Do you see the difference between ray OP and ray PO? Ray PO means it's starting from P and then it's going through O. But OP is starting at O going through P. That is something that students will be tricked on some sort of question in a test, and you need to memorize that. Throughout this slide there will be problems and you need to memorize that. Okay? That's also something we will be focusing on in this section of the lesson. So 3. It is referred to as line AB. Is that correct? No, that is incorrect. First of all, both of these are incorrect. This needs to be a capitalization. So points, they all need to be capitalized. So both of these are incorrect. Okay? And number 4. It is referred to as line segment BA. Is that correct? And mind you, this little point sticking out here, ignore that. That wasn't there on purpose. It's just that, when we made it, kind of went through, but yes. So it stops at A and B. Is that line segment BA? First thought, students will think, no, because of the order. But rays are the only 1D figures that needs to be ordered when naming. So this is correct. You can look at it from the other way as well. It doesn't matter for lines or line segments. 5. Please use 2 ways to represent the lines in the figure. So from what we learned on over here, you can probably do it yourself of this going across kind of, the ways. Because, of course, if you jotted them down on the other slide, you would have gotten these correct. So I'm not going to go over it. I'm sure that you can solve it on your own. Anyways, 6. As shown in the figure, do the lines AB and AC represent the same line? Lines AB and AC. Do they represent the same line? Correct answer, yes. They do represent the same line. Line AB will be this line because all it has to do is align. And then remember, a line can extend on either way as long as they're the same kind of degree. So since they are the same, they will represent the same line. It's just that BC, it kind of goes a bit over B through B, but really that's just drawn on there. Really the line is continuing forever on both sides, probably out of this screen. And this AB is the same. It's also going to run off the screen. 7. How could you represent the ray below with point O as a start point? So with point O as a start point. Okay, how can you? There are 3 ways to do this. Remember, rays, you have to memorize their order. The first letter shown in there, as say ray AB, that A, it will be the start point. So memorize that. Well, we already know point O is a start point, so all 3 of these different namings for this ray will have to start with O. And then there's OA, starts at O, crosses through point A. OB starts at O, goes through point B, and OC starts at O, goes through C. 8. Are the rays OB and BO the same ray? Why or why not? Requirement. Follow drawing below. So seems like this. Okay. So if we made something that's OB, so it starts at O and it goes through B, and then we made another ray that starts at B and goes through O, will they be the same ray? Why or why not? We just talked about it. So rays, they need a order. So OB and BO, the letters are in the different order. So then it will be, no, they're not the same ray because the order is different. Their meanings are different. For example, OB means we start at O, we go through B. But BO will be we start at B, the starting point's already different, and we go through O. So it's different directions. We need them to be the same direction in order to be the same ray, and of course the same degree. Now we have some examples. From the practices we just had, I assume you already know lots about expressing rays, lines, line segments. So let's look at this problem. Looking at the figure below, which of the following statements are correct? Now, I trust you can do this, or at least you can try to. So I am challenging you to pause the video and do this problem. After, you'll come back unpause and we'll reveal the answers together. Solve the problem? Great. So let's look first at option A. Lines AB and CD are different lines. Well, this figure, of course, AB, it just means line that goes through A and B, and CD, line CD will be a line that goes through C and D. On this figure, they are connected, they're going the same direction, they're at the same degree, that means no. A, B, and CD are the same line. So we're finding for which statements are correct, so we're gonna cross out A. Rays AB and BA are the same ray. Now let's look at option B. Rays AB and BA are the same ray. So what would ray AB look like? Ray AB will be start at A, go through B. That will be start at A, go through B. BA will be start at B, go through A. But on this line, it will be one going that way and the other going that way. So their directions are already different, even though their degrees are the same. And we already talked about this many times. Rays, they need to have an order. So B is also incorrect. Now we have it down to C and D. Let's look at C. Line segments AB and BR are the same line segment. Yes, that is correct. That is our answer. Because line segments and lines, they don't require a order like rays do. Because the order will never ever matter. AB, you flip it around, it'll be the same as BA. Just switch the names of the points. So that is correct. But even if we have C, we'll still have to look at D just in case somehow we had a mistake with C. So D, it says line AD is equal to AB plus BC plus CD. Okay, so this is definitely incorrect because right now they're talking about lines, not line segments. If it were line segments, this will be correct. But right now it's talking about lines. Okay, well, AD. AD is a line that goes through from point A to point D, and it goes on forever onto both sides through these 2 points. AB is just drawn shorter on this page, but it will still continue on in the same direction forever and forever onto both sides, the same as AD. So does BC and CD. So line AD is not equal to AB plus BC plus CD because they are all equal. So D is also incorrect. Now the answer is C. Let's look at example 2. Okay, that's example 1. Now practice. Which of the figures following represent ray AB? And 2, which of the representations of lines are correct? I want you to solve all of these problems, write your answer on your page, and then after unpause, we'll go over the answers together. Wasn't too hard, was it? Okay, number 1. Which of the figures represents ray AB? Okay, so we first need to cross out all of the figures that are not even rays before we even look at anything else. A is definitely incorrect. It's a line segment. So is D. That is a line. Now we have it down to B and C. Okay. Ray AB will start at A and go through B. And it seems like, what does this drawing look like? B, right? So the answer is B. Because, look, for C, we started at B and we went through A, so that would be ray BA. Again, order matters for rays, so C is also incorrect and the answer is B. And second problem, which of the representations of lines are correct? Line AB. Remember, for points, when we are marking points, any point on anything, it has to be capitalized, 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 capitalized. Always remember that for points. So this option A will be incorrect because for the points, A and B are lowercase. B, well, only one of them is capitalized and it's not line A. That's incorrect. Line C, yes, that is correct because the points they are capitalized, and for D, well, this isn't line A. This is point A, so this is also incorrect. The answer is C. Example 2. As shown in the figure, 3 points A, B, and C are on the plane. Now we're being asked to draw ray AB, draw line BC, and draw ray CA. I want you to quickly jot these dots quickly on your notebook, and after we'll come back, we'll go over the answers together. Great, now you're back. So first we have to draw ray AB. Ray AB. Okay, so this computer's answers are kind of, I don't know why, but I'll just draw myself with this green pen. So draw ray AB. It's a ray in order matters. We start at A, we go through B. So we're gonna go through B. Remember to draw that arrow right there to indicate it's going to the right. 2, draw line BC. It is a line. We have to make sure we kind of go through both points and then draw the arrow to indicate it goes forever on as a line. And then draw ray CA. Order matters. We start at C, we go through A. Start at C, go through A, indicate it with the arrow. Done. 4. How can you get ray in line AB from line segment AB? So how can you get the ray and line AB from the line segments AB shown here? So pause the video, draw it out, then come back. So this isn't asking for any more of you than just extending it to make it become ray in line AB. First one, we want to have ray AB. Well, we extend it through B. Remember, there is a catch here. What if I decided to extend it through A? Would that be a ray anymore? At least, will that be ray AB anymore? No, because then that will be ray BA. So it's really important for rays that you remember it has to go through B because it's ray AB. Okay, now we're doing line AB from line segment. So it just has to go through the point A and point B. So it goes through, there's the line AB or BA. 5. How many points does the lines AB and BC share? So how many points does the lines AB and BC share? Okay, solve this problem by yourself first and then come back. Do you see how easy this question is? First, you just have to draw the lines AB and BC. You draw them, and then you see that how much points do they share? They share 1 point, which is B. So that's the answer. It's not asking for any more of you than. Now let's do activity number 1. How many line segments are in the figure below? Explain your analyzation of the problem. Well, let's do this together. How many line segments are in the figure below? We need to count them in an order here. First, there's green. There's 1, and then there's 2, 3, 4. So there's 4 from A. Now we're going to go to B. I'll switch to another color, probably a light blue. So starting from B, we can't go back to A because that'll still be the same line segment as AB and it already exists. So we're going to go to C, which is BC, then BD, last one, BE. Now C, we'll do so we did a 3, right? So 3, I'll write that down. Now I'll do A, orange, starting from C. 1, 2. Remember, we're not overlapping because then if we overlapped, that's what some of the line segments we get will be repeated. And then, of course, there will be the last one, D. That will be purple, and that's just 1. So we add all of these together, we're going to get 10. So look at this, it's the same analyzation. So the line segments with A as a start point are AB, AC, AD, AE, a total of 4. And the line segments with B as a start point is, and not repeating with the front, are BC, BD, and BE, a total of 3, with C at the start point, not repeating with the front. There are CD, CE, total of 2 line segments, and with D as a start point, and the line segment does not overlap with the previous start points, has DE, a total of 1. So there is a total of 4 plus 3 plus 2 plus 1, 10 line segments. The sentences and practice. Find out how many line segments, rays, and lines can you observe from the figure below. Mark the line segments. Okay, well, first we need to do the line segments. So I'll write segments for that. Line, and then ray. Ray. Okay, there. First, we have to find out the line segments. And remember, it says to mark the line segments. Well, we're just going to first start from A, we're going to do AB, AC, that's already 2, and from B, 1, so that's 3 line segments. So 1, 2, 3. Okay? And then we are going to do the lines. How much lines are there? For the lines, there's line AB, line AC, line BC. There are also 3 lines. And then for the rays, well, remember as last time, each point they can make 2 rays. There are 3 points, so there's 6 rays. So try to draw the 6 rays yourself. Well, there's 1, 2 from A, 3, 4 from B, 5, 6 from C. There. Now, remember from the beginning of that lesson, something really confusing was saying 2 points form a line or 2 points determine a line. This is when we are going to get into that. So here's a discussion. How many rays can be drawn from point O? How many points can be drawn from point O? There's a random point called O. How many rays can be drawn from it? How many rays? So infinitely many, almost like a circle. How much radiuses, different radiuses can it have? Not in the value, but like how much can you draw? It can have as many as it's infinite. It's infinite. So if this was point O, it'll have much more lines than that. It'll go on forever and forever. And our second question is, how many lines can be drawn from connecting points A and B? Only one line can be drawn from point A and B. Now I want you to think for a moment. How is that different from the rays drawn from point O? And what is making that difference? Think about that. What is making the difference of that line AB can only have one line, but from point O there can be as many rays as you want from it? Okay, here's the answer. Because this line can only have one line because there are 2 points. These 2 points are almost like the 2 nails you can use to stabilize a piece of wooden plank on a wall. Because say you're trying to attach a wooden plank onto your wall. If you only use one nail on one end, it's loose. It can go anywhere. The other end can go anywhere you want. It can spin all around that one point. But with 2, which is 1 on either side, it can stabilize that, and it can only go in one position, which is that horizontal position you want to be in, or in this case, diagonal. But these rays, they have more freedom. They only have 1.0. They don't have a second point. They're determining here's where you start, here's where you end, here's where we have to go through, and then you have to go through this. No, it just has to have one start point, which is point O, and you could go on any direction you'd like. As long as, of course, it's straight. You can't go like this. That's not going to be a line. So the conclusion is that there can only be one line passing through 2 points. That is 2 points determines a line. That's point O. Here's what I just said. If you want to fix a thin wooden strip to the wall, what is the least amount of nails needed? And what is the basis for this? So if you want to stamp this onto a wall, what is the least amount of nails you need to staple that on the wall? 2. You could do 3, you could do 4, you could do 100, but you only need 2. Now let's practice some of the concepts that we've been learning before. Okay, give an example that reflects there is only one line through 2 points. So 2 points determines one line, or 2 points forms a line. How can we give some examples of that? Well, for one, we can do, when planting trees, you can determine the straight line of tree pits in the same row by locating 2 tree pits at the end of the row of trees. So what this is saying is, like in some big cities like Boston, Beijing, some sort of big city like that, on the sides of roads, you might sometimes see rows of trees planted. And you might know that those trees are usually planted in these pits where they plant the trees. So when planting the trees in the tree pits, we just first need to plant 2 trees in their pits, and then connect those 2 trees by planting some more trees in the middle, and that'll have the row of trees. So there's these 2 trees, and then from these lines, we keep going planting some trees. There, we have a whole line of trees. Now we have some practice. Among the following statements, the false statement is blank. And I'm not going to read problem 2, but I want you to do both of these problems, and then we're going to come back and review them. Okay, so you're going to come back, and so what did you go for the first one? Among the following statements, the false statement is blank. A. Let's start with eliminating some answers. A. There can be infinite possible lines going through a point. A point, which is 1 point. Yes, that is correct. But remember, we're trying to find the false statement. So B, there's only one line going through 2 points. That is also correct. A line can only be marked by one letter. We need to go back to that. And the line segments EF and FE are the same line segment. That is correct. So what is our answer? C. But we know that the answer is C because of the elimination, but I still want to go over it because it's not a test, it's practice. So I want to go over this. A line can only be marked by one letter. Is that true? No. Let's first just draw a line. The line is line, you know what? I'll erase it. The line is line X, Y. Is this line marked by only 2 letters? I mean by one letter. No, there's 2 letters, X and Y, point X and point Y. And another way, of course, would just be this is a line that goes forever on, and we can call it line B. A lowercase letter, one lowercase letter can represent a line, and 2 uppercase letters that represents 2 points can also determine a line. So there are 2 ways to create a line like that. 2. The following phenomena. 1. Peasant planting seedlings in rows. 2. Soldiers aiming at targets. 3. Students' morning exercise. Geeks are aligned. And at least 2 nails must be used on a wall to fix the wooden strips. And number 5. Straightening the curved river to shorten the voyage. Among them, 2 points form a line. Can explain blank. So looking at all 5 of these phenomena, we need to pick some that the saying 2 points from a line can be describing. The answers are 1, 2, 3, 4. Peasant planting seedlings in rows. You have to plant them in rows, those are lines. Soldiers aiming at targets, those are also lines the bullet is going into. 3. The students' morning exercises are aligned. Students in some countries in the mornings they do some exercises. If you don't, and usually it's in these like aligned lines. So yes, that's also aligned. And number 4, at least 2 nails must be used on the wall to fix the wooden strips. That was one of the things we went over earlier. Number 3, when 2 straight lines intersect, there is a maximum of 1 point of intersection. 3 straight lines intersect, the maximum of 3 points of intersection. When 4 straight lines intersect, how many points of intersection are there at most? I want you to think about this, and then we're going to come back and do it together. Well, I'll draw it. So we have 2 lines intersect. There's 1 point intersecting. Let me get my yellow pen. 1 point intersecting. 3 lines intersect. There's 3 points intersecting. And for 4, there can be 1, 2, 3, 4, 5, 6 lines intersecting. 1, 3, 6. Now we have a class summary. We learned all about line segments, rays, and lines, which is our introduction to a geometry unit. Units. And we study the relationship between line segments, rays, and lines, and that we learn all about the saying 2 points determine one line, which is knowing all about how 2 points, it can only be one single line going through 2 points. Okay, so first skill was understanding the relationships between line segments, and rays. Second skill, knowing how and using different methods to represent line segments, and rays. Remember we talked in the beginning, we learned all about the different methods of how to represent them. And then we understood the meaning of 2 points from a line or 2 points determining a line. So I hope you enjoy this lesson, and I'll meet you next time for lesson 4.2.